Welcome to a new episode of our statistical analysis course. In this video, we will talk about tests of group differences, independent sample t-test, and one-way ANOVA test. In our flow diagram, we will begin by the tests in the group differences column, where we will discuss the case when you have a continuous first variable. If your second variable is dichotomous, you will reach independent sample t-test. And if your second variable is ordinal or multinomial, you will reach one-way ANOVA test. Take into account that your assumptions are met. Independent sample t-test. The three main assumptions for this test are: Assumption 1, no outliers. Assumption 2, normal distribution. And Assumption 4, homogeneity of variance. Recall the assumptions from the assumptions episode. To do the independent sample t-test, go to Analyze, then Compare Means, then choose Independent Sample t-test. Remember that this test is used when you have a continuous variable which you add to test variables box, and a dichotomous variable, which you add to the grouping variable box. Then assign the two groups of the dichotomous variable. For example, 1 for male and 2 for female. Click OK. To report the results in your paper, begin by mentioning the mean and standard deviation for each group. You can use the following words. The mean age for men was 47.71, standard deviation 8.9. And the mean age for women was 49.6, standard deviation 8.1. Then you state the mean difference between the two groups. The mean difference between groups was -1.89. And the 95% confidence interval was -4.3 to 0.5. And finally, state the p-value, and if it was significant or not. The p-value was not statistically significant. P equals 0.120. Remember that we chose the results from upper row, because Levine's test p-value was more than 0.05. One-way ANOVA. The three main assumptions for this test are: Assumption 1, no outliers. Assumption 2, normal distribution. And Assumption 4, homogeneity of variance. To do one-way ANOVA test, go to Analyze, then Compare Means, then choose one-way ANOVA. Remember that this test is used when you have a continuous variable, which you add to dependent list box, and a nominal or ordinal variable, which you add to the factor box. Then from the Options button, choose Descriptives. So SPSS will show the mean and standard deviation for each variable. Click OK. To report the results in your paper, begin by mentioning the mean and standard deviation for each group. You can use the following words. The mean age for the nun group was 52.1, standard deviation 8.2. And for high school group, it was 46.3, standard deviation 8.5. For college group the mean age was 46.9, standard deviation 7.9. And for high degree group, the mean age was 48, standard deviation 6.7. State the p-value and if it was significant or not. The p-value was statistically significant. As you can see in this example, we have a p-value of 0, which if you click on it for details, it turns into 0.000148. Keep in mind that you do not need to report any number below 0.001. In such cases, you can just report that your p-value is less than 0.001. Remember that we chose the results from the upper row because Levine's test p-value of more than 0.05 is there. Note that we did not report the difference between the groups in a similar manner to what we did with the independent sample t-test, because we do not know between which two groups exactly is the significant difference we got. To get all of these, we do what is known as post-hoc analysis, which is a Latin word that means post-test analysis. To do this, do the same steps for the one-way ANOVA test. Note that you have Posthoc button. This box shows the Posthoc test available for you on SPSS. The easiest test to report is the 2-key Posthoc test. Click Continue, and then OK. In the output table, the SPSS compares each group with the other groups each at a time. So in the first row, we have the none group compared with all the other groups, and the mean difference with its significant level are reported beside each comparison pair. Note also that there is an asterisk beside each comparison with a significant p-value. You can think of this post-hoc analysis as performing an independent sample t-test between each two groups. So you can use similar words to those used with independent sample t-test when you report your post-hoc test results. The mean difference between none group and high school group was 5.8, and the 95% confidence interval was 2.24 to 9.34. The p-value was statistically significant less than 0.001, and so on for each comparison pair.